Welcome to the DIY Honda Garage channel. Welcome to the diagnostic session for DTC P0202, which indicates a malfunction in the number 2 cylinder injector circuit on the Honda Pilot models from 2016 to 2022. This code relates to issues within the fuel injection system, specifically affecting the injector responsible for delivering fuel to the number 2 cylinder. Understanding this malfunction is critical, as it can lead to poor engine performance, misfires, or even engine stalling. During this session, we will explore the components involved, probable causes, symptoms, and an extensive troubleshooting approach to effectively resolve the issue. By the end of this presentation, you will have a clear understanding of the steps needed to diagnose and fix the problem associated with DTC P0202. The DTC P0202 error signifies a malfunction in the number 2 cylinder injector circuit. This circuit is critical for the proper functioning of the fuel injection system, with components including the powertrain control module, PCM, injector relay, and the number 2 fuel injector itself. The injector relay is responsible for supplying power to the fuel injector, while the PCM monitors and controls the fuel injection process. The number 2 fuel injector is located on the engine's intake manifold and is crucial for delivering fuel at the right moment during the combustion cycle. If there's a failure in any of these components or their connections, it can trigger the P020 code. The diagnosed issue needs to be addressed promptly to prevent further engine damage or performance issues. Several possible causes can trigger the DTC P0202. First, a malfunctioning injector relay may fail to provide the necessary power to the number 2 injector, leading to an error. Additionally, open circuits in the wiring can disrupt the electrical flow needed for accurate injector operation. Poor connections, corroded terminals, or loose wiring are common issues that can interrupt the circuit. Furthermore, a faulty powertrain control module PCM may miscommunicate commands, affecting injector activity. Lastly, issues with the connector terminals at any key points in the injector circuit can lead to performance failures, resulting in this DTC. When experiencing DTC P020, various symptoms may manifest that signal a problem with a number 2 cylinder injector circuit. An engine misfire is one common symptom, characterized by irregular firing of the engine cylinders. This misfire can lead to increased vibration and noise from the engine. Consequently, poor acceleration can occur as the fuel supply to the engine is compromised, affecting performance during driving. Drivers may also notice a rough idle where the engine struggles to maintain a consistent RPM, leading to stalling or unexpected shutoff. Notably, these symptoms are imperative to monitor because they can point towards underlying issues within the engine and fuel system that require immediate attention. The first troubleshooting step involves verifying the problem status. Begin by turning the vehicle to the on mode without starting the engine. Next, clear the DTC using the Honda Diagnostic System, commonly referred to as HDS. This step resets any existing error codes and allows for an accurate assessment of the current vehicle condition. After clearing the DTC, start the engine. If you have a keyless access system, continue cranking for 20 seconds if the engine does not start immediately. Following these actions, check for any pending or confirmed DTCs using the HDS. This will help determine if the DTC P0202 persists, indicating that the failure is consistent and requires further investigation. In this step, you will assess the outcome of the previous engine start attempt. If the vehicle started successfully, it indicates that the initial issue may have been an intermittent failure, and you should proceed to the next step, which is step 11. On the other hand, if the engine does not start This suggests a more persistent problem with the injector circuit. Understanding the engine status at this point is crucial, as it guides the subsequent diagnostic processes to pinpoint the specific issue related to DTC P0202. Confirming whether the engine starts or not will impact your troubleshooting direction significantly. So careful documentation of the results will aid in further steps. For step 3, begin by turning the vehicle to the off lock mode to ensure safety when handling electrical components. Next, remove the injector relay from the under-hood fuse relay box. The injector relay is a crucial electronic component that controls the power to the fuel injector. With the relay removed, perform a thorough test to diagnose if the relay is functioning correctly. This is done using specialized equipment or a multimeter to verify the relay's continuity and functionality. If the injector relay tests faulty, it will need to be replaced to restore the proper flow of electricity to the number 2 injector. If the relay is confirmed to be operational, then you will proceed to the next diagnostic step to further explore potential issues. In step 4, the vehicle should once again be turned to the on mode. It is crucial at this point to ensure that the injector relay remains disconnected. Using a multimeter, measure the voltage between specific test points, namely between test point 1 at the injector relay 4P socket number 3 and test point 2 at a clean body ground. This measurement will help confirm whether battery voltage is present at this circuit. If battery voltage is found, it indicates that the circuit between the power source and the relay is intact, and you will then progress to step 5. Conversely, if there is no voltage, it suggests an open in the IGP wire, necessitating repair of the circuit between the relay circuit board and the injector relay to restore functionality. For this step, switch the vehicle to the off lock mode again while ensuring the injector relay remains disconnected. The next task is to measure the voltage between specific test points. This time, from injector relay 4P socket number 1 to a reliable body ground. This procedure will determine if there is battery voltage present through the +B engine line. If voltage is present, proceed to step 7, as this indicates that the power supply line is functional. However, if no voltage is detected, it requires an inspection and possible repair for an open in the +B engine wire. The goal of this step is to ensure that the entire circuit leading to the injector relay is fully operational before moving on to further diagnostics. In step 6, review the condition of fuse number A12, which is a 20 amp fuse located in the underhood fuse relay box. This fuse plays a critical role in protecting the electrical circuit that connects the power source to the injector relay. Visually inspect the fuse for any signs of damage or blown filaments. If the fuse appears to be intact, it suggests that the circuit is functioning correctly, and you'll need to repair an open in the +B engine wire between the fuse and the injector relay. However, if the fuse is found to be blown or damaged, it will need to be replaced, and the subsequent wiring associated with the fuse should be checked for potential short circuits. This step is a vital diagnostic point, as a blown fuse can disrupt the entire injector circuit. Continuing with the diagnostic process, step 7 starts with turning the vehicle to the on mode while keeping the injector relay disconnected. This time, the objective is to measure the voltage from injector relay 4P socket number 3 to socket number 4. This diagnostic check is crucial in determining if there is adequate battery voltage present in the INJ-RLY line. If voltage is detected, it indicates that the circuit within the injector relay is functional, and you should then escalate your diagnosis to step 9. Conversely, if there is no voltage, further investigation will be necessary at the wiring levels, particularly in the INJ-RLY line, where continuity issues might exist. For Step 8, turn the vehicle back to the off-lock mode and prepare to jump the SCS line using the HDS. You will need to disconnect the PCM connector A51P before proceeding to check for continuity. The test will involve checking continuity between injector relay 4P socket number 4 and the PCM connector A51P number 17. This test will show whether the INJ-RLY wire is functioning properly. If continuity exists, it confirms that there are no faults or interruptions in the wiring from the injector relay to the PCM. However, if continuity is absent, it indicates an open in the INJ-RLY wire. Should DTC P0202 be indicated, substituting a known good PCM to observe if the DTC clears is advisable. If it does, replacing the original PCM becomes necessary. Step 9 involves turning the vehicle to the off mode again. Begin by disconnecting the injector control module connector D4P and then jumping the lines at the injector relay 4P socket number 1 and number 2. You will then measure the voltage between injector control module connector D4P number 1 and a known body ground. This test is critical because it checks the functionality of the INJ-RLY out IGEDU1 line. If voltage is present, it indicates that the wiring between the injector relay and the injector control module is intact. Conversely, if you find no voltage, it suggests an open circuit in the INJ-RLY out IGEDU1 wire that will require repair to restore proper connectivity. Continuing with Step 10, you will remain in the off-lock mode. If necessary, ensure to remove the jumper wire from the injector relay 4P socket and reconnect the connector for the injector control module D4P. The next step is to measure the voltage at injector control module connector D4P, number 2, while referring to a good body ground. This test verifies the integrity of the INJ-RLY out IGEDU2 line. If voltage is present during this test, it suggests there are no disruptions in this specific wire. Should there be no voltage, it indicates the possibility of a break in the INJ-RLY out IGEDU2 wire that would need repairing to ensure proper voltage delivery. In Step 11, turn the vehicle to the off-lock mode. If necessary, disconnect the earlier established jumper wire before reinstalling the injector relay. Reconnect the injector control module connector D4P if it was previously disconnected. You will also need to jump the SCS line using the HDS and allow a minute of wait time for the actions to take effect. Next, disconnect both the injector control module connector C12P and PCM connector B51P. The objective is to check for continuity between injector control module connector C12P number 1 and PCM connector B51P number 15. This part of the test will confirm if the INJ-TI2 wire is intact. If continuity is confirmed, it indicates no issues in this wire, while absence of continuity highlights a potential problem requiring further investigation. For Step 12, you will need to leave the vehicle in the off-lock mode and disconnect the PCM connector C51P. The next granularity check involves continuity between injector control module connector C12P number 4 and PCM connector C51P number 19. This test wraps around verifying the INJ F3 line for continuity. If continuity is confirmed, there are errors elsewhere that require rectification. If no continuity is present, it indicates an open circuit in the INJ F3 wire, which will need to be repaired to restore the circuit integrity. Conducting this continuity check is essential in isolating problems within the wiring harness. In Step 13, you'll disconnect the Injector Control Module Connector A, 6P, to set up for a continuity test. This check requires isolation of the injector module from other components. Using a multimeter, measure for continuity between test point 1, which is connector A number 3, and test point 2, which this time should correspond with number 6. This test will identify if there is a fault in the circuit linked to the INJ-HS2 line or INJ-LS2 line and reveal potential faults. Continuity presents, confirms operational status along that pathway. However, if continuity fails, it suggests further investigation into the wiring linking the injector control module and the injector itself. Step 14 focuses specifically on the number 2 cylinder injector 2P connector. Prior to proceeding, ensure it is disconnected completely from the harness. You're checking for continuity between the number 2 connector's terminal number 2 and the injector control module connector A, 6P number 3. As you test, confirm that the connections are clean and free from corrosion, as this can greatly affect results. If continuity exists, it verifies the integrity of the INJ-HS2 wire, allowing you to proceed towards Step 15. Should there be no continuity detected in this test, it points towards an open fault in the INJ-HS2 wire, necessitating repair to maintain continuity and ensure proper injector performance. As we dive into Step 15, the focus remains on assessing the functionality of the INJ-LS2 line. To execute this, you will check continuity between number 2 cylinder 2P connector number 1 and injector control module connector A, 6P number 6. Proper testing conditions still apply, ensuring the vehicle remains in the off-lock mode. If continuity is confirmed through this check, it will indicate that the circuit linking the injector control module and the number 56 injector, 2 injector, is intact. However, if not, this signals an open fault in the INJ-LS2 line and warrants immediate repair. Upon finding continuity, it will be essential to replace all injectors as a set to maintain uniform performance across the engine. In Step 16, the vehicle should be again turned to the on mode to verify operations within the INJTI2 line. You're measuring voltage levels at injector control module connector C, 12P, number 1, while referencing a body ground. This check identifies whether there is any short to power present in the INJTI2 wire that might be causing malfunctions in the cylinder's injector performance. If you detect voltage, further actions will need to be taken to repair that short within the wiring, impacting the relationship between the injector and the control module. However, if there is no voltage, the issue resides elsewhere, necessitating additional diagnostics. For Step 17, you will continue with the vehicle in the on mode. Here, focus on measuring voltage at test points between injector control module connector C, 12P, number 4, and a body ground. The purpose of this measurement is to determine if there is any short to power within the INJ-F3 line. If voltage exists at this point, it indicates a short that requires immediate attention to prevent further damage in the electrical system. Conversely, if you find no voltage, it suggests that the wiring is intact, allowing you to move on to the next diagnostic step. Step 18 requires the vehicle set to off mode while isolating the number 2 cylinder injector 2P connector. Once this is done, switch the ignition back to on and measure the voltage between injector control module connector A, 6P, number 3, and a body ground. This test is crucial for identifying any short to power scenarios within the INJ-HS2 line. Should you find voltage, this indicates a flaw in wiring that will need to be repaired. as it compromises the injector circuit's integrity. If no voltage is present, further diagnostics are essential to isolate the failure point within the circuit leading to the injector. In this step, the approach remains consistent, as you are set to measure voltage between injector control module connector A, 6P, number 6 and a body ground. This test targets the INJ-LS2 line for potential short circuits that might be hindering the normal operations of the number 2 injector. If voltage is present, this short would require addressing to prevent circuit failure. If there is no voltage detected, this further indicates that the wiring remains intact, leading you towards the next area of testing to verify the health of the electrical circuit. Transitioning into step 20. Ensure the vehicle is in the off-lock mode. The assessment involves checking continuity between injector control module connector C, 12P, number 1, and a body ground. This step verifies if there's a short to ground condition in the INJ-TI2 wire between the PCM B15 and the injector control module. Establishing continuity indicates no failure on this front, which is promising. If continuity is absent, it highlights a need for repair within the INJ-TI2 wire to restore function. This granular look at wiring conditions is crucial for validating the circuit health. For step 21, you're tasked with checking for continuity between the specific points at injector control module connector C, 12P, number 4, and ground. This operation assesses the potential for short to ground conditions present in the INJ-F3 wire between the PCM, C19, and the injector control module. If continuity is established between these points, it signifies that the connection is sound and functioning as expected. However, should no continuity be detected, it denotes a short circuit to ground that necessitates prompt attention to ensure the injector performs well. In step 22, the focus shifts back to the wiring around the injector control module. Check for continuity between injector control module connector A, 6P, number 6, and ground. This assessment checks if there's any potential for a short to ground scenario impacting the INJ-HS2 wire linked to the number 2 cylinder injector. Confirming continuity in this context ensures that the wiring remains intact and functional as designed. However, if continuity is absent, a short circuit in the wiring has likely developed, warranting immediate investigation and repair to restore the system to operational status. Step 23 involves conducting a final continuity check between the INR-LS2 line to identify short conditions. The focus remains on querying whether continuity exists between injector control module connector A, 6P, number 6, and ground. As before, this helps establish whether a shorting condition has occurred within the wiring. Confirming continuity denotes a clean circuit, allowing for injector functionality. Conversely, if absent, it opens the pathway to repairs necessary for the wiring circuit to reinstate its integrity between the injector and control module. In the final step, 24, you'll disconnect the number 6 cylinder injector 2P connector while maintaining the system in the off position. After it's isolated, the vehicle should be turned to the on mode to measure voltage between the injector control module connector B, 6P, number 2, and a body ground. This measure is crucial for identifying whether a short to power exists in the INJ-HS6 wire, ultimately affecting injector performance. If voltage is present, focused repairs to the affected wire are critical. In case of no voltage, testing can shift toward interpreting other underlying electrical issues, possibly originating from the injector control module, needing further exploration. Final repair verification is a crucial step in the diagnostic process. After taking the necessary repairs, ensure that all work is confirmed thoroughly. guaranteeing connections are secure and wiring integrity is restored. Clear any diagnostic trouble codes, DTCs, once more, using the Honda Diagnostic System to reset the PCM's memory. This step is key to check whether the P0202 code reappears. Finally, conduct a test drive of the vehicle under various conditions to confirm that the issues have been resolved and that the engine runs smoothly without further indications of injector circuit malfunction. Monitoring the vehicle post-repair allows technicians to ensure that the repairs made effectively addressed the initial problem. Preventive maintenance plays a vital role in ensuring the longevity of the injector system and overall engine performance. Regularly checking wiring can catch issues before they escalate into serious problems. Inspect connectors for signs of corrosion or damage, as this can hinder proper electrical flow and lead to malfunctioning components. Additionally, cleaning the fuel injectors periodically helps prevent carbon buildup, ensuring efficient fuel delivery and better engine performance. Establishing a routine maintenance program can save both time and cost in the long run, ensuring that conditions remain optimal for engine operation and minimizing the risk of trigger faults like DTC P0202. In conclusion, DTC P0202 indicates a malfunction in the number 2 cylinder injector circuit, leading to various performance issues. Understanding the role of each component, cause, and symptoms involved allows for a structured troubleshooting approach to effectively diagnose and resolve the underlying problem. It is crucial to follow each step carefully to ensure that all potential issues are addressed. Furthermore, preventive maintenance not only helps to sustain vehicle performance, but also reduces the likelihood of encountering future DTCs. By being proactive and systematic, you can extend the life of your injector system and ensure that your Honda Pilot operates at its best. Please like and subscribe to the channel. See you next time.